Hey team, this is Philip Moore from Gizmo Data. I want to talk to you today about Spark Connect and a project that I'm really excited about at Gizmo Data. We've created the Spark Connect Proxy, which adds a security layer to let you easily and securely connect to a Spark cluster that you have running on the cloud or on-prem, for example. In this video, we'll be covering using Spark Connect Proxy to connect securely to EMR and Amazon Web Services or AWS. So if you're familiar with Spark Connect, you know the architecture looks like this. It lets you, connect a notebook or a programming language like Python or whatever to use the Spark Connect API to talk to the Spark driver. So the Spark driver can be in the cloud, in AWS EMR, for example, and you can actually leverage that over the internet with Spark Connect. And older Spark, the notebook had to be on the driver, so you actually had to manage the cluster yourself with the notebook. And that was not ideal, obviously, because the notebook would have to have a lot of resources to be able to manage that Spark cluster, to be the driver. So Spark Connect totally changes that. But the problem is that Spark Connect doesn't have a security layer, and that's where this Gizmo Data Spark Connect Proxy comes in. All right, so here's the repo for the Spark Connect Proxy. It is a repo that we created, and it lets you secure the Spark Connect server. So you say, hey, why do this? So there's a link right here in the README that describes why. So it jumps right here, and you can see in Spark's documentation that while Spark Connect does not have built-in authentication, it's designed to work seamlessly with your existing authentication infrastructure. Well, that could be a little bit unclear, right? What if you don't have an authentication infrastructure? That's where the Spark Connect Proxy comes in. All right, so in the repo here, you can see we have some installation instructions from PyPy. You can clone the repo, which I've done for this video for development purposes. And you can use some scripts, some handy scripts to provision an EMR Spark cluster and then connect remotely from your laptop or a Jupyter Lab notebook on the internet if you wanted to connect to your EMR cluster. So one of the important things here is that what we've done in EMR, we've opened up public access to port 50051. You say, well, wait a minute, that's scary. And indeed it is a little bit because you're basically saying, hey world, you can talk to my Spark cluster. But fear not, because we've added a security layer that makes you, one, have to authenticate with a token, and two, it uses TLS to secure or encrypt the communication to and from the Spark cluster so that someone can't intercept your token or your data traveling to and from the cluster. All right, so we have in here the repo that we've cloned, and I went ahead for the purposes of this video, I went ahead and ran this script in the scripts directory called provision EMR Spark cluster.sh, and it goes ahead and it provisioned a small Spark cluster in EMR. I went ahead and reduced, just for the purposes of cost, I just used an R5.2x large for the machine type, and I'm using 3 instances, so that's 1 driver and 2 workers. And I'm using Spark EMR version 7.2.0. So that provisioned an EMR cluster. If we go here to my cluster here, you can see the properties. You can see it's waiting and waiting for traffic to go ahead and get started. And it has in here it has a DNS entry and so forth to be able to connect to it. So you can see here's the public DNS address. But again, we need to be able to connect to that securely. So that's where this proxy comes in. All right, so we've provisioned this cluster, and one of the output artifacts of this is this log. And the log spits out an example of how to interact with your Spark EMR cluster securely using the Spark Connect Proxy. So you'll notice here, one of the things here on the remote, it outputs the URL. So it's going to have that public DNS entry, and that you'll notice there's that port 50051. It's going to use SSL equal to true, and it spits out a token that it automatically generated on the cluster to be able to securely connect to it. So, say, well, Phil, why are you putting your token in this video? Well, this cluster will be long gone, and this token is ephemeral, so it changes every time you provision the cluster. So you can use the token if you want, capture it from this video, but it won't do you any good. So I have a notebook here that I'm going to go ahead and interact with that Spark cluster. So this notebook is on my laptop, and the Spark cluster and EMR cluster is running in Amazon Web Services, right? So it's on the internet. So we'll go ahead and import the necessary libraries, and we're going to import IBIS because IBIS is an awesome Python library to interact with your data engines like PySpark or whatever, and do it in a Pythonic manner and use it like data frame logic instead of writing raw SQL. All right, so the next cell, we do have to set this environment variable to give it a path to our certificate authority that the Spark cluster created. And that just tells our Spark proxy client, hey, you can trust this SSL certificate from the Spark cluster, because in this case, we just did a self-signed certificate. And we're going to get a Spark session here. We're going to app name as test, and we're going to connect remotely to that URL, that Spark context URL with our public DNS name, use SSL equal true, and then our token to securely authenticate. So let's go ahead and run that cell. And it looks like we've got a connection. Now the cool thing is here, we're going to read, using spark.read.parquet, we're going to read an open Parquet data set here that's public from S3. And we're just going to show the top 10 rows. So that's actually running on the Spark cluster, not on my laptop. And it securely transmitted that data, and we just showed those 10 rows here in this df.show. So the other thing too is we're going to use IBIS. We're going to ibis.pyspark.connect, and we're just going to pass in that Spark connection, that Spark session. And that will allow us to use IBIS to interact with our data. And in this case, we're going to read that Parquet file, and we call it a table named T. And then you can see here we're doing some IBIS Pythonic data frame logic here, where we're doing a t.select those 3 columns. We're doing a filter or like a where clause. We're limiting to 10,000 rows. We're grouping by species, and we're getting account aggregation. We're going to execute that IBIS expression, and then we're going to display the result. All right, so we'll go ahead and execute that. We get some Python warnings here, just pretend that doesn't exist. and you're going to see here, you get a species column, and you get a count of species from that Parquet data set. So you can see using this repo available on the Gizmo Data GitHub organization, you can easily spin up an EMR cluster, and you can securely and remotely connect to it from a Jupyter notebook, and be confident that other folks are not going to be able to connect to your Spark cluster. So Spark Connect, again, in summary, a very powerful tool for running a Spark cluster remotely and be able to connect to it from a remote client. But it doesn't have that security. So Spark Connect Proxy from Gizmo Data, an open source project, will easily allow you to secure that Spark Connect cluster, a Spark Connect server. So if you have any questions or concerns, or you want support, or you want to know how to use this for your organization or business, please contact Gizmo Data today at info@gizmodata.tech, and we'll be glad to talk to you and help you get going with that. Thanks very much, and have a great day.